One of the greatest challenges of space travel is the problem of extreme distance. The distances of the universe are beyond vast, and one of the major arguments in astrobiology as to why we do not see aliens everywhere, including our own solar system, is because the distances involved are simply too great for anyone to reasonably cross. But this viewpoint is actually somewhat misguided because the universe actually allows two ways past the distance problem without leaving known physics. The issue, though, is that either way you go requires you to sacrifice time. You must always give something up, and to do any of these methods, we one way or another are going to end up in the future. But even just living life as we all do is an exercise in moving into the future. It's called age, but that can be altered drastically in the extremes of physics. The first way to circumvent distance in the universe is to travel at relativistic speeds. Some will say to just do it through upper dimensions, but that's a unicorn. We don't know how to do that, or if the universe allows it. But within known physics, there is a way. There is an effect in special relativity that gives a rather odd loophole to the distance problem. It's velocity time dilation. In theory, you can get into a spaceship and accelerate to high relativistic speeds, very high, near the speed of light. But if you could do that, the effect is that massive amounts of time pass outside your spaceship, and thus massive amounts of distance do too. Therefore, you can cross most of the observable universe within a single human lifetime. More if you extend your lifetime. The problem is that if you do that, you will end up in the distant, far future, with no way to connect back to your own time. There are many technical problems for doing that, and we're not close to that capability. But in principle, the universe does let you do it. And this also means that crossing a galaxy at relativistic speeds is actually doable in a short amount of time in your frame of reference. But as Cooper said of Newton's third law in Interstellar, you've got to leave something behind. In special and general relativity, what you leave behind is time. The universe always costs. The second way is good old-fashioned slow space travel, as we know and love it. Here you also leave behind time because, well, it takes time to get to a destination. If that destination is Proxima Centauri, you're going to leave a lot of time behind. With current technology, we have a plan with Breakthrough Starshot to send a group of microprobes connected to light sails to Proxima Centauri pushed by a laser. We can do this right now with our tech, and through that plan, it is physically possible for us to reach up to 20% the speed of light and get the probes there within 20 to 30 years, depending on speed, and then do a flyby. A long time, but not that long. And those probes will not care about the passage of time because they are machines. It's all the same to them. This can be scaled up to a much more capable probe with future technological development. This is of course the concept of a von Neumann probe that can self-replicate and self-repair. It is, in effect, a 3D printer that can use the raw materials of a star system to repair itself and make copies of itself indefinitely into the future, and at sublight speeds can put a probe in every star system in the galaxy within a few million years. The galaxy is only 100,000 light-years across. Time also shrinks distances. While a functional, immortal machine, perhaps artificially intelligent, isn't going to care about the passage of time like a biological being would, ones that only live on average 80 years. Such a machine has most of the time in the universe ahead of it, trillions upon trillions of years. I've spoken many times on von Neumann probes, but there actually is a further question about them to explore. So the motivation of such a probe could well be scientific, though it also could be military. For the military option, it may be advantageous to station a kill probe in star systems with developing life, just in case a technological civilization appears that could present a threat to the rest of the galaxy. This is a scary solution to the Fermi paradox because it would mean that the reason we do not see alien civilizations everywhere is because something out there circumvents them when they accidentally and irresponsibly approach a dangerous technology that could be a threat to the police civilization, such as some way to end the universe hidden in the physics we aren't aware of yet and won't be until it's too late. The scientific motivation, on the other hand, would be just that: study the life of the universe. It's sometimes argued that alien life would have no interest in us. We're just too primitive, and they wouldn't bother to study us. I do not think that's very compelling, however, based on our own activity. We put a large amount of resources into studying the most primitive life on Earth, the microbes. This is done for both science and medicine, so we take interest in the very simple ourselves. If we drill into Europa or an ice shell moon and find bacteria analogs that are not related to Earth life, yet are very simple as far as life goes, that would rank amongst the most important discoveries in human history. It could just as easily be that even highly advanced aliens like to see what microbial life in the universe can do, and it might be that much more interesting if it gets past the filters and produces a civilization. Such arguments cast aside the notion that highly advanced alien civilizations want information, are inquisitive and scientific, and pursue the study of life, history, civilization wherever they find it, no matter how advanced or primitive it is. So we remain intensely interested in alien life of any flavor, and that may be the case for aliens as well, especially if the Fermi paradox is resolved by life or intelligence simply being rare. In that case, any occurrence of it would be of great scientific interest to anyone. A highly advanced alien civilization isn't necessarily stupid, or they wouldn't be where they are. It doesn't matter how advanced you are, you still want to know whether you are alone in the universe. That may lead alien civilizations to post von Neumann probes in any system that has a planet that might produce an abiogenesis event, and then just monitor it across the entire history of life on that world. This would interestingly lead to a weird potential effect that actually is plausible. If such a probe exists in the solar system, then it might possess a record of the entire natural history of planet Earth. Think photographs of dinosaurs, early Earth, and so on, a full record. And maybe even advanced data on physics that we do not currently have. That, if it told us, leads us to a quantum leap in scientific understanding. That when it makes contact, when we're sufficiently advanced to understand it, it hands us that data as a gift of goodwill. Even better if it has taken genetic samples of species from the past for resurrection. There are many possibilities inside of a positive contact with an alien probe in the solar system should one exist. But there are also negative possibilities. One might be as if they gave us technology we don't understand that destroys us. An alien Trojan horse, for example. Give the hominids a bomb they don't understand, right when they become a security threat to the advanced, ancient dominant species of the Milky Way. Have it crash on their planet to trick them into back-engineering it so it destroys them. Or it may not be a bomb, but a technological trajectory that leads us to ruin, or a return to the Stone Age. You could call that intelligent up-and-coming species management. That too is a solution to the Fermi paradox, in that all civilizations are allowed by an invisible overlord civilization or group of civilizations to reach a certain level of overall technology, only to do repeated resets when needed to ensure the hegemony of the first technological civilizations to arise in a galaxy. There can be only one, as it were. Regardless, however, von Neumann probes have classically been seen as using the resources of a star system in space to self-replicate or 3D print. They have been envisioned to mine asteroids or comets or moons or something of that nature, but there are other options. In 2001, A Space Odyssey, Stanley Kubrick and Arthur C. Clarke envisioned them doing it at Jupiter, ultimately turning it into an artificial star. That's actually really problematic on a hard science basis, but that's what the monoliths ultimately were for as far as their chief function, though they did seem to be multi-purpose. If such a scenario were to play out at Jupiter, that isn't the best option. It's a whole lot of hydrogen and helium and relatively little else until you go so deep you reach the core, where you can't easily get metals and other heavier materials, then gases like hydrogen condensed into liquid forms. There is an easier way. Don't bother with a gas giant and its gravity well and dense gases. Use the terrestrial worlds for your resources if they are present in a star system. Yes, they have larger gravity wells than an asteroid, and asteroids may do, at least for some things as far as materials, but an asteroid does not have the resources of Earth itself, or for that matter Mars. So it might be that von Neumann self-replicators might favor the habitable worlds of star systems, or those like Titan that have abundant hydrocarbons for easy access to materials. As an aside, we obviously know that Earth has oil, which is useful for making plastics, as is life in general. And that oil is produced through the action of rotting biology. But it can't actually be ruled out yet that Mars, if it had abundant life in its past history, doesn't also have oil. Many jokes are made that if we ever found oil on Mars, it would be colonized within a year. But the reality is that transporting oil from Mars to Earth is not feasible. It would be so ridiculously expensive by the time it got here that there are just better alternatives when you locally run out. But it might be useful for a Mars colony, at least for a period, just as it was for Earth. Though maybe not so much for energy production, but for plastics manufacturing and warming the Martian atmosphere. That's the weird benefit. If you burn oxygen derived from Martian ice to produce carbon dioxide as a byproduct of manufacturing, well, what's the difference? It will just warm up already cold Mars, which already has a thin atmosphere of mostly carbon dioxide. Climate change on that planet just means terraforming. But here's the creepy thing about all of this. So if a von Neumann probe wanted to use Earth for its raw materials, where exactly would it go? Say it's more interested in the resources of Earth than it is the asteroids or other planets. Well, on this planet, land isn't all that different. Though there are still important differences from an asteroid. The asteroid will give you more things like the element iridium and some rare metals. But if you want aluminum, well, it's very abundant in the land masses of Earth, which is why we make beverage cans from it. But is there a better option? There may actually be, and it's the oceans. The oceans contain a lot of resources, actually many resources. Earth's oceans have everything from metals to heavy water to oil within them, and dissolved metals of many types. They are very rich and largely untapped. Case in point, the oceans are littered with fields of manganese nodules that we've barely touched, that could be used for mining. That's an area of active interest for prospecting. However, it's worth noting here that if an alien von Neumann submarine in the oceans were doing that, and would have been doing it for a very long period of time, those would have been depleted, and they are not. We still have them. They appear fully natural, and are just sitting there, and a source of many rare earth metals that doesn't look like it's ever been tapped by anyone previous to us. But the nature of a von Neumann machine is very simple. Work with the materials you have available to you in the star system you are in. That would be an amazing machine indeed, that could mine, refine, and manufacture on its own like that. But a cell phone would be equally amazing to someone in the Middle Ages. But this would lead to an odd effect. So the key to the origin of materials as to where in the solar system or beyond are from is isotope ratios. We can tell where a meteorite in the solar system is from through that method. And it's also the basis for trying to figure out why we have a moon. It has very similar isotope ratios to Earth, which is why we think it was slung off Earth in a massive impact event. The isotopes of other moons and planets will be different, interstellar even more so. The thing is, if you're using metals from Earth in your 3D printing, they would not really be distinguishable from the isotope ratios of the rest of Earth. You could tell they were manufactured, but you couldn't really easily tell if they were made by an alien von Neumann probe versus our own technology. Worse is if it were made by an alien self-replicating, self-repairing von Neumann probe millions or billions of years old, that's been here since the beginning of life on Earth or before. Maybe it even seeded it originally and let it take its course as a form of artificial panspermia. Maybe over its ancient existence it's taken too many cosmic ray hits, and now it's corrupted and only semi-competent, and behaves irrationally and not quite on point. Maybe saying such a thing might be an exercise in Arthur C. Clarke's statement that any sufficiently advanced technology is indistinguishable from magic, and thus may appear to behave irrationally. So admittedly, I have gone full-on speculative, hard science fiction author with this scenario, but I do think it is plausible and within the laws of physics as we know them. Perhaps not very likely, but I leave it up to you to decide what this scenario resembles. Interesting indeed. Happy, very belated Halloween indeed. Thanks for listening. I am futurist and science fiction author John Michael Godier, currently worried about a day when it's the aliens hiding our existence. Maybe that's how it works. The reason we don't get a SETI signal is because nobody except one species of alien actually knows about our existence. And that particular species keeps it secret from all the others so that nobody ever contacts us. Very disconcerting, and be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.